The tunnelling industry continues to help communities and cities evolve, but what is sometimes forgotten is the extraordinary durability of underground infrastructure. From ancient Greece, where the Samos tunnel heralded the advent of geometry, onto engineering advancements developed into the Iron Age, where Kanat technology was invented in ancient Iran as a way to redirect water to arid land. The technology spread from Rome to Oman, to Turpan in China, and on to the Americas. Every tunnel structure degrades over time, so regular examination of older tunnels, with inspectors checking the ground above for movement and engineers drilling test holes to look for cavities, are all regularly carried out. Contactless monitoring systems are being developed further to move through tunnels robotically, as well as digital image correlation, laser scanning, and other regular upgrades. Tunnels are built to last, but eventually elements need upgrading and replacing. In France, the Malpas tunnel on the Canal du Midi was excavated in 1679 and was Europe's first navigable canal tunnel. When the canal build encountered brittle sandstone, the tunnel was lined with stone vaulting, creating a wide and high 165-meter long tunnel. The Malpas tunnel is still in excellent condition and in constant use today. The 275-meter-long Staple Bend Tunnel was constructed between 1831 and 1834, forming part of the Allegheny Portage Railroad, the first railroad constructed through the mountains of central Pennsylvania. Both ends connected to the Pennsylvania Canal to help primarily as a portage railway, hauling riverboats and barges over rivers. The Lützburg single-bore twin-track tunnel opened in 1913 after a 6-year build. It's a 14.5-kilometer-long rail tunnel cutting through the Bernese Alps in Switzerland at the highest point of the Swiss railway network. The original tunnel and line are still in use, and a new Lützburg base tunnel has been constructed adjacent to the original tunnel, running some 400 meters below. Construction of the 7.7-kilometer-long Tana Tunnel in Japan was undertaken to speed up travel by cutting through the Hakone mountain range. Maintenance has included combating water seepage from soft rock formations and hot spring water vents, and improving tunnel lining with regular draining. The Thames Tunnel was initially built for horse-drawn carriages, but eventually used by pedestrians and tourists before being repurposed as a railway tunnel, and today connects with the London Overground. Aware of the historic aesthetics, a short section at one end of the tunnel was left untreated in upgrading, with delicate treatment of the rest of the tunnel. The tunnel crown is only a few feet from the river water, and more than 3,000 litres of water are pumped out of the tunnel every day. The Mont-Cenis tunnel lies under the Fréjus Pass, running from France to Italy. The 13.6-kilometre rail tunnel was constructed between 1857 and 1871, and the project utilised new techniques. To this day, the Mont-Cenis tunnel remains an important link in the connection between Rome and Paris, and the tunnel was enlarged in 2010 to allow transport of container trucks. With parts of the London Underground tunnel network more than 150 years old, successful maintenance is essential to control water seepage and corrosion of track and structures, as well as fixing disruption to signalling and surface deterioration of other electrical systems. These major upgrades have brought much of the line into the 21st century. Budapest Metro is the oldest electrified underground railway system in Europe. Opened in 1896, the metro is made up of 4 lines that run in different directions. It was constructed for passengers to travel from the city centre to the city park, and the original iconic Line 1 remains unaltered and in use, with the help of major upgrades. New York's infamous Great Blizzard of 1888 reinforced the city's ambition to take commutes underground, and the first underground line opened in 1904. The tunnels are designed to withstand some leaking, but pumps still run continuously, diverting water seepage back into the sewers. Crews routinely repair the grouting and caulking and inject a substance to create a waterproof membrane outside the tunnel. After the impact of Storm Sandy, also in New York, the Hudson River Rail Tunnel is now facing a possible upgrade, with major electrical upgrades. In 1896, Miguel Canet, the former mayor of Buenos Aires, had been inspired by the London subway, and the new underground transportation system was approved to work alongside the existing tram network. It took 2 years to build, and was the first underground system in Latin America and the Southern Hemisphere. In Rio de Janeiro, major impact of the metro tunnels were also carried out for the Rio Olympics. To remedy the problem of increasingly insufficient transport and the prospect of the 1900 Paris World Fair, an underground option in Paris was approved, designed from the outset as a system of 9 lines. The lines have been extended both west and east, with works to adapt the tunnels for electrics by increasing tunnel height, adding screen doors at platforms lengthened to take 6 cars, as well as tunnel-mounted aerials for Wi-Fi and continuous video transmission from each car to the control unit. The major long-term goal of the industry is to construct tunnels that are not only cost-effective and safe, but also able to remain in use well into the next century and beyond.